Assalamu alaikum everyone. Dear students, I hope all of you are doing well. We are starting mechanics paper 4 of A-level math 9709 today. Let's talk about forces and equilibrium. This will be our first chapter of paper 4. It's not only a talk, we will cover all the concepts related to forces and equilibrium in today's lesson. Let's start with the definition of force. It is a factor which produces or tends to produce acceleration in any object. Now, if you did not have physics in your O level, no need to worry about the definition because they will never ask you any definition in your paper 4. Now, let's talk about the resolution of forces. You can see you have a diagonal force in a coordinate system of x-axis and y-axis. Now this force is making angle theta with x-axis. What is the resolution of force? You can see that the force is a diagonal force. It means if you move along this vector, you will be moving in two directions. You will be moving horizontally as well as vertically. So we need to find its horizontal component and vertical component. You have done vectors in your O-level math. You can see that if you resolve this diagonal vector into these two vectors, you will have these two vectors like this will be fx, the horizontal vector. This will be fy, the vertical vector, and this will be the resultant of these two vectors. You have seen this diagram in O level. Now, what we are supposed to do? We are supposed to find the horizontal and vertical part of this diagonal force. You can see that you have a right angle triangle here in which if you apply sine theta and cos theta, you will have sine theta is equal to fy over f and cos theta is equal to fx over x. So these two expressions will be representing the horizontal and vertical component. This is the horizontal component of this force and this is the vertical component of this force. Now, how to find the expression for the resultant of these two components? This is the horizontal component, this is the vertical component, and this one f, it is basically resultant of these two forces. You know the Pythagoras theorem, it's a right angle triangle, and if you apply the Pythagoras theorem in this triangle, you will have this equation, f square is equal to fx square plus fy square, and finally you will have the expression for the resultant of forces, and this will be the direction of force. You can see that in this right angle triangle, if you apply tan theta, that will be opposite over adjacent, so you will have fy divided by fx. So the expression for theta will become tan inverse of fy over fx. That will be the direction of the force f. Now this is the basic formula. You can also have this formula like this. This will be equal to f is equal to square root of summation fx square plus summation fy square. This is basically sum of all horizontal forces Similarly, summation fy square, this will be sum of all vertical forces. Plus, you can also have the expression for direction of the forces, direction of the resultant force, that will become tan inverse of summation fy divided by summation fx. So, first of all, you need to remember these two things, that what is the horizontal component of any force and what is the vertical component of any force. And then you will have to remember these two expressions. This expression is for the resultant of any force, resultant of all the forces, and this is basically the direction of any force with the positive x-axis. Now let's talk about equilibrium. Equilibrium. Basically, if sum of all forces at any object is equal to zero, we will say that the object is in the state of equilibrium. There are some conditions, but all the conditions are related to physics. Right now, for this chapter and for this component of A level math, we will be using this definition. Equilibrium means sum of all forces is zero. That is, all sum of all horizontal forces is equal to zero. Similarly, sum of all vertical forces will be equal to zero. Now, this expression or this equation can be written as all backward forces will be equal to all forward forces. And this one, sum of all vertical forces will be equal to zero. It means that all downward forces will be equal to all upward forces. So whenever you have a question for equilibrium, you need to use these two conditions, that sum of all horizontal forces as well as sum of all vertical forces is equal to zero. You have a very important theorem that is called Lem's theorem. Let's suppose you have three coplanar forces. For example, look at this one and this one and this one. You have three coplanar forces. Let's suppose this force is F1, this one is F2, and this one is F3. Now, we have a condition that these three forces are coplanar. F1, F2, and F3 are coplanar. Coplanar means these three forces are lying on the same plane. And let's suppose the angle between these two forces is alpha, and the angle between these two forces is beta, and the angle between these two forces is gamma. Now, if these three forces are equilibrium, if F1, F2, and F3 are in equilibrium, you can use this formula, which is basically sine rule of trigonometry. You can have F1 or sine alpha is equal to F2, or sine beta is equal to F3, or sine gamma. This is called Lem's theorem, and this is a very useful theorem, especially when you have three forces in the state of equilibrium. You can use this formula for this type of condition. Now, next thing, we will talk about friction. Basically, this is the force which opposes the movement or motion between two surfaces. The force which opposes the motion between two surfaces. This is called friction, and the basic formula for friction, that will be F is equal to mu R, and the symbol for friction is usually small f. Now, mu is basically the coefficient of friction, and it will be given in your question. Sometimes it will be given, and sometimes you will have to find this. And next thing is R. It is basically normal reaction force, and it is always perpendicular to the direction of movement. Always perpendicular to the direction of movement. For example, you can have some cases in your examination. For example, look at this thing. This is a table, and this is an object like this, and the object is moving in this direction along table, and you can have an inclined plane like this. This is the angle of the inclined plane, and the object is moving in this direction along the inclined plane. Or you can also have this condition. This is a vertical rod, and there is a ring which is moving along this vertical rod. Now we will see that what will be the direction of this thing, the normal reaction. Basically, I have told you that it is always perpendicular to the direction of movement. So in this case, when the object is moving horizontally, the direction of R will be perpendicular to the movement. Similarly, here the direction of movement is along the inclined plane, so the direction of normal reaction will be in this direction. You can see that this is the direction of movement of particle, and this direction is perpendicular to the direction of movement. Similarly, in this case, you can see that the ring is moving vertically, so the direction of R will become like this. So this thing is very, very important, that you need to see that which will be the direction of normal reaction. Now there are some types of frictions, very, very important. You have seen the expression for the friction, that will be mu times R. There are some types of friction. First of all, you have static friction. Usually it is denoted by Fs. This is the friction when both surfaces are at the state of rest. You know, sometimes you are applying a force on a table or any other object, but the object is not moving even after the application of force. It means that both objects are at rest. And why the object are at rest even after the application of force? Just because of friction. So this type of friction, in which objects are at rest, is called static friction, when objects are at rest. Then we have kinetic friction. This is usually denoted by Fk. This is basically the friction when object is moving. You know, sometimes you are dragging an object, you are applying force on a table, and table is moving, but still there is a friction between table and the surface at which table is moving. In that type of condition, when objects are moving, the friction will be called kinetic friction. When objects are moving. Now there is another thing which is very important, because this term will be used in your questions, that is called maximum static friction. Maximum static friction, and sometimes this is called limiting friction. Now you can see from the name of this friction that it is the maximum amount of the static friction. After this amount there will be no static friction, because this is the maximum value of static friction. If you increase the force, and if force increases above the maximum static friction, it means that object will start moving. You can see a diagram like this. Let's suppose this is the applied force on x-axis. This is applied force, and on y-axis you have friction. So look at this thing. From point O till point A, this is the friction which is called the static friction. It means that on x-axis you have the applied force, the external force, and on y-axis you have friction. And from point O till point A, both quantities are increasing with each other. Like applied, you are increasing the applied force, the external force, and you can see that friction is also increasing. But let's suppose this is the point where you have maximum static friction. After this point, look at the graph, it will become like this. Now this is the kinetic friction. You can see from this point here that this is the point which is representing the maximum static friction. If you increase your applied force after this point, the static friction will become the kinetic friction, and the object will start moving. And you can also see that the kinetic friction is always less than the maximum static friction, because in case of static friction, the object is always at rest. So the particles or the molecules or atoms of both surfaces are joined with each other. That in that type of case you will have the static friction. But in case of kinetic friction, one object must be moving in case of kinetic friction. So the objects are moving. It means that the molecules and the atoms of both surfaces are not joined with each other. So in that case, there will be less friction as compared to the case in which the particles or molecules of both surfaces are joined with each other. So you can see that the kinetic friction is always less than the static friction. So this is a small diagram to understand the relations between static friction, kinetic friction, and maximum static friction. Now all these things are related to physics. In your mathematical questions, you will have to use this terminology, limiting friction, and sometimes you will have maximum static friction. Now let's talk about some questions about friction and the concepts we have done so far. Look at this question, and if you read the statement, First of all, in diagram 1, a block of mass 2 kg is at rest on a horizontal floor. The coefficient of friction is mu. You don't know about mu. A force of 12 Newton is acting at an angle alpha, and you have a value for tan alpha. When the force acts downward, it means in figure 1, the block remains at rest, or you can also say that it is in the state of equilibrium. You need to show that the mu is greater or equal to 6 by 17. So first of all, let's resolve the forces in diagram 1. You can see that the force of 12 Newton, it is a diagonal force, and we have seen in the part of resolution of forces that whenever you have a diagonal force, you will have to resolve that force into its components. This will be the horizontal component of this force, and I've told you in previous part, let's see again, that the horizontal component is F cos theta and the vertical component will be F sin theta. So in this diagram, the horizontal component of this 12 Newton force will be 12 sin alpha, and the vertical component of this force will be, the horizontal component will be 12 cos alpha and the vertical component will be 12 sin alpha. Because you can see that the force is acting downward. You can see the direction. It is acting downward. So its vertical component will be downward. Otherwise, in this case, the vertical component will be upward and the horizontal component will be forward in both cases. Anyways, we are solving figure 1 right now. You have resolved these two forces, plus you can see that the object is moving forward, and you need to remember one thing about friction, that it will be always against the movement. The force of friction is always against the movement. You can understand that this direction will move forward. This object will move forward in any case. It will never move backward. So this object is moving forward. It means that the force of friction will be backward. Plus, you can have two vertical forces. First of all, you know about the formula for weight W is equal to mg. It means that weight of this object will be 2 times 10. You know that the value of g is 10 throughout the paper for mechanics. So the weight will become 20. Weight of the object will be 20 newtons. Plus, this will be the normal reaction. So these are the forces which can be used in this diagram. This is a complete force diagram for figure 1. Now we can see that the block remains at rest. It is given in the statement, this thing, that the block is at rest. It means that the block is in the state of equilibrium. And you can also say that all left forces will be equal to right forces and all downward forces will be equal to the upward forces. So we can resolve these forces like this. First of all, we will see all parallel forces. You have two parallel forces. Left force is F and the right force is 12 cos alpha. Similarly, if you see the perpendicular forces, you have three forces. One force is upward, which is R, and you have two downward forces, 12 sin alpha and 20. So in the state of equilibrium, all the upward forces will be equal to all downward forces. So you will have these two equations, 20 plus 12 sin alpha. Now let's talk about sine alpha and cos alpha. You can see that tan alpha is basically 3 by 4. So you can construct a random right angle triangle to find sine alpha and cos alpha. You know that tan alpha is always opposite over adjacent. It is opposite over adjacent. So this will become, this side will be 3 and this side will be 4. And if you apply the Pythagoras theorem here, let me enlarge the triangle. This side is 3, this side is 4, and this angle is alpha. If you apply the Pythagoras theorem here, this is the right angle triangle, you can find this side by using Pythagoras theorem. So in this triangle, now you can see that sine alpha, that will be opposite over adjacent. So sine alpha will be 3 by 5 and cos alpha will be adjacent over hypotenuse, that will become 4 over 5. So if you put all these values over here, you will have F is basically mu r, you know about this, friction is equal to mu r, and cos alpha is basically 4 over 5. And similarly, let's talk about this equation. This is basically r is equal to 20 plus 12 sine alpha, and sine alpha is 3 by 5. So r will be, let me open my calculator, this is basically 20 plus 12 times 3 by 5. That will be 136 over 5. And if you put this value over here, you will have mu times 136 by 5 is equal to 48 divided by 5. So mu will be 48 by 136, and if you simplify this, that will become 48 divided by 136, that will be 6 by 17. But you can see that the block remains at rest. Now there is a condition that if you want the block to be at rest, if block is at rest, the coefficient of friction must be greater or equal to 6 by 17. Because if it is less than 6 by 17, then there will be less friction and the object or the block will start moving. Now in this case, you can see that the block is at rest, so the coefficient of friction must be greater or equal to 6 by 17. Now let's talk about the second part. In this part, in figure 2, the block slides along the floor. Find another inequality, like you have the inequality for part 1 for mu. Look at this diagram. Again, we will construct a force diagram. First of all, look at the diagonal force, it's 12. So you will have 12 cos alpha for this component and 12 sine alpha for this component, and you have r and weight for this object, and plus again the object will be moving forward, so the force of friction will be backward. Now if you see figure 2, the parallel forces, the equation of parallel forces will remain same, because again you have a backward force which is friction and a forward force which is 12 cos alpha. So if you equate these two forces, you will have F is equal to 12 cos alpha. But look at the vertical case. In case of vertical forces, this force 12 sine alpha, it is now upward. So there is a slight change in the equation for vertical components. We will modify this. I'm going to erase this one. We can change this equation now. You can see that upward forces, which is R and 12 sine alpha, and the weight is basically 20 newtons. So you will have 20 is equal to R plus 12 sine alpha. So R will be equal to 20 minus 12 sine alpha, and you know that sine alpha is 3 by 5, so we can have R 20 minus 12 times 3 by 5, so R will be 64 by 5. It will be 64 by 5. So this equation will be mu R is equal to 12 times 4 by 5, and mu and R is basically 64 by 5. So you will have 48 over 5, and mu will be 48 by 64. Or you can also simplify this, 48 by 64, you will have 3 by 4. But you can see that the block slides along the floor. It means in this case mu must be less than 3 by 4, because if mu is greater than 3 by 4, the force of friction will be greater, and this will stop the object to slide. So in this case the inequality will be mu must be less than 3 by 4. So let's move to next question. All right, look at this question. A small ring of object of mass 0.2 kg is threaded on a fixed vertical rod. This is the ring of mass 0.2 kg, and the end A of a light inextensible string is attached to the ring, and the other end C is attached to a fixed point. This is the fixed point at which the other end of the string is attached, and a horizontal force of 8 Newton is applied to the point B. Now basically the string was vertical like this, A, B and C, but from this point you have a force towards right side, and if you apply the force, this string will become the string will become in this shape. Now find the tension in the part AB, in this part, and in the part BC. So first of all you can find the angles. Let's suppose this force is T1, and this force is T2, and you are supposed to find T1 and T2. You can see that you have a right angle triangle, and you can apply Lem's theorem, because you can see that these three forces are coplanar forces, and sum of these forces is 0 because the system is in equilibrium. So at this point B, you can see that you have a force 8 Newton, and this force is T2, and this force is T1, and the angle between T1 and T2 is 90 degrees. From the diagram you can see this, and if you find this angle, you can find this one. Basically you have a right angle triangle, so if you find this angle, that will be tan, let's suppose this is theta, so tan theta will be equal to 1.5 divided by 2. So this angle will become 1.5 divided by 2. This angle is 36.9. This angle will be 36.9. And so this angle will be 90 plus 36.9, because you can see that any angle, any exterior angle is basically sum of opposite interior angles. So if you add 90 in this angle, you will have 126.8 or 126.9. This angle will become 126.9. So at point B, you have this angle 126.9. Now you can also find this angle. This will be 360 minus 90 minus 126.9. So you will have 143.1. This angle will become 143.1. Now you can apply simple sine rule, which is called Lem's theorem in this case, to find T1 and T2. You can see that the angle which is opposite to T1 is 143.1. So you will have T1 divided by sine 143.1. That will be equal to 8 Newton. And you can see that the angle which is opposite to 8 is 90 degree. So that will become 8 sine 90. So T1 will be equal to 8 sine 143.1. So we can have 8 sine 143.1. That will become 4.8 newtons. This will be the tension in part BC. Similarly, you will have T2 divided by sine 126.9, and this will be 8 over sine 90. So in this case, T2 will be equal to 8 sine 126.9. So that will be 6.39. This component of force will be 6.39 newtons. So this is the simplest way to solve this type of problem. Otherwise, you can also solve by resolving forces, but that will be a lengthy method. Now let's talk about part 2. We will have to find the coefficient of friction between ring and the rod. So let's make a diagram around the ring. Basically, this is the ring, and if you talk about the forces which are acting at this ring, this is the force which was basically the tension T2. Basically, tension T2 was pulling this ring towards this direction, and it is acting at point B towards this direction. When we will study this chapter about connected particles or Newton laws of motion, we will study this concept in detail, that that force of tension is basically dual-sided. It will apply equal force in both directions. So the force T2, it will pull the ring in this direction, and it will apply a force at point B at this direction. Now look at this force T2. You have just calculated it is 6.39 newtons, almost 6.4 newtons. Plus, you can see that the ring will move vertical, it will move upward or downward. So the direction of R will be perpendicular. Plus, you can see that this angle, you can find this angle from here, like if you see, this angle is basically tan inverse of 2 divided by 1.5, so that will be 53.1, and this angle is basically 90 minus 53.1, so you will have 36.8. This angle is basically 36.8. 36.8. Now let's talk about the resolution of forces. This component and this component. This component will be 6.4 cos theta, so you will have 6.4 36 cos 36.8, and this component will be 6.4 sine 36.8. And we have another force which will be weight of this ring. You know that mass of the ring is 0.2 kg, so weight of this ring will be 2 Newton. Plus you can see that the equilibrium is limiting with the ring on the point of sliding up. Sliding up means that the friction will be downward, because it is on the point of sliding up. So it will be, if it is moving, it will be moving upward, so the friction will be downward in this case. So these are all the forces for this part. If you write all the vertical forces and perpendicular forces, horizontal forces, sorry, you will have these equations. For the parallel forces, you have R is equal to 6.4 cos 36.8, which will be, if you use the calculator, 6.4 cos 36.8, that will be 5.12. So R will be 5.12 Newton, but we are supposed to find the coefficient of friction. So you can use these are this was the equation for the parallel case. Now for vertical case, you can have F plus 2. These are two forces which are downward, and sum of these two forces will be equal to upward forces. So that will be 6.4 sine 36.8. And you know that F is equal to mu R, that will be 6.4 sine 36.8 minus 2, and that will be this R, it will be coming in the denominator. So for mu you will have 6.4 sine 36.8 minus 2 divided by R, which was 5.12. So that will be 0.359, 0.359, because you are supposed to write answer in 3 significant figure. So I think I'm looking at time, and the time of video is showing 44 minutes. So we will solve rest of the practice questions in our next video. Plus a very important part of this chapter will be done in second video, which is I think in second or most probably in third video, which is inclined plane. Very important part of this chapter. So I am ending this video here. In second video we will solve some practice questions about resultant forces, resultant of forces and direction of forces, and then for the inclined plane. Thank you. See you in second video.